Hey, algebra students, I hope you guys had a great weekend. I'm looking ahead to some problems that you'll see this week. So I just wanted to start off by introducing a few problems to you that you will come across. So let me share my screen with you. Excuse me. All right, let's look at the first problem here on the top of the page. It says the function of x is equal to 2 times 5 raised to the 2x. That's the same as the function of x equals 2 times 25 to the x power. So basically, you can go ahead and raise 5. Go ahead and say, okay, well, what is 5 squared? So of course, 5 squared is 25, and so that's how we go from here to here. So what if I said the function of x is equal to 4 times 2 raised to 3x? We could go ahead and keep the 4. We could say, all right, what is 2 to the 3rd power? So of course, 2 times 2 times 2 is 8. So the first expression and the third are equivalent, okay? So my question is, what is the equivalent of the function of x is equal to 3 times 4 raised to the 3x? So 4 times 4 times 4 is 64. So that's the answer. The function of x is equal to 3 times 64 raised to the x. Those are equivalent. Now, we don't know what x is. You could plug in any value you wanted to for x to figure out what the f of x is, right? All right, so one of the things we're going to look at is compound interest. So if you ever put money in the stock market, you will earn compound interest on it. Or in this case, Paula's putting her money into a savings account. So the way you find the compound interest is always the same. You start with the principal. That's how much money you put down or put into an account. And then they're going to always add 1 to your interest rate. And then that is to the power of x, and x represents how long you're going to keep your money in an account. So the longer you keep your money in an account, the more money you'll make. So Paula puts an initial $100 into a savings account. So that's her principal. So the principal, that's the starting place. So on a graph, that would be your y-intercept. The account has a 3% annual compound interest rate. And one thing we always are going to do with rates is turn them into decimals. So 3% is 0.03. Create a function that models Paula's savings account, how much money will be in her account after 5 years. So we're going to say the function of x is equal to her principal times 1 plus her interest, 0.03, raised to the time she keeps her money in the account. Now, that's our function, and then it says how much money will be in her account after 5 years. So now, instead of having an unknown variable, we know that that x is going to be a 5. So we're going to multiply 100 times 1 plus 0.03 is 1.03 raised to the 5th power. So of course, order of operation tells us that we must do exponents first. So 1.05 raised to the, whoops, it's not a 5, it's a 3. Raised to the 5th power times 100 is, oh, I didn't say times 100. Whoops, let me start over, I'm sorry. So it'd be 100 times 1.03 in parentheses raised to the 5th power. And the answer is 115. Where? Okay. So my answer is $115.93. So you're like, oh, that's not very much money. She only earned almost $16. That's true, but her amount that she put in there was very small. And for 5 years, she didn't do anything. She didn't work. She didn't go get a job. She didn't labor. And she earned $16 just for letting her money sit in the bank. So that's not bad. But obviously, the more money you put in, the more money you're going to make, right? All right, so it's not always money. Sometimes nature gives us compound interest type situations. So letter B says a certain forest covers an area of 2,000 square kilometers. Suppose that each year this area decreases by 6%. So that's compounding. That's compounding year after year after year. How much area remains after 12 years? So we start out with our beginning amount of acreage or squared kilometers. And now we always, that's a 1 right there. 1, normally it's plus because with interest you're earning. However, this is decreasing by 6%. So to show decreasing, we're going to subtract 0.06. And this time our time is 12. So our acreage, our square kilometers is shrinking. So 1 minus 0.06 is 0.94. So 0.94 raised to the 12th power. So I'm going to plug that right in my calculator. I'm going to use parentheses exactly like I see it, 2,000, parentheses, 0.94, parentheses, raised to the 12. The answer is, in 12 years, I only have 951.84 kilometers left, squared kilometers left. So it's half the size it used to be. The forest covers half the size of ground it used to cover. All right, so this couple of units these lessons, we're talking about growth and decay. So look at the 2 graphs. So remember, you always read a graph from left to right, just like you read words from left to right. So the first graph, if you read it from left to right, it's going up. It's going up and to the right. The graph on the bottom, if you read it from left to right, it's going down and to the right, down and to the right. So the top one is showing growth. Since the line goes up and to the right, it's showing growth. The graph on the bottom is showing decay because it's going down and to the right. Now, if you don't have a graph, there's a couple of other ways you can tell when a function is showing growth or decay. So whatever the number that's being raised to that exponent is called the base. If your base is greater than 1, that means that whatever it is that you're graphing or looking at is growing, is showing growth. So 2 is definitely greater than 1, right? 1.04 isn't a lot greater than 1, but is greater than 1. So both of these functions is going to be is showing us that both of these functions represents growth. Now for decay, the number inside the parentheses, which is the base, if that number is between 0 and 1, that means that our graph is always going to show decay. It's going to be a negative picture, negative slope. Well, not a negative slope, but it goes down and to the right. Okay, so you always look at the base. If it's greater than 1, it's showing growth. If it's less than 1, like both of these on the bottom, it's showing decay. All right. So that first number doesn't really, it's not that important. It's not, see, like this one, this is less than 1, but it's going to be growth because the base is greater than 1. So don't look at the first number, look at the base. All right, now the y-intercept, of course, is our starting place. It's always where our graph crosses the y-axis. And the way you find, so the compound interest formula is right here on the bottom. The top one is the kind of graphs we were just looking at. So if we want to know our starting place, we want to know our place where our line is going to cross the y-axis. For the top equation, it's always the first number or letter A. That is our y-intercept. And for our compound interest formula, y-intercept is always capital P, the principal. How much did you start with? How much did you put down? All right, so let's look at this graph. So we have an equation, and this equation graphed is right here on this graph. So the first question is this graph showing growth or decay? So two different ways we can tell. First thing is we look at our base. Since 4 is greater than 1, we know it's showing growth. The other way we can tell is by looking at our graph. From reading the blue line from left to right, it's going up and to the right. So both of those things tells us that this is showing growth. The function and also the graph shows growth. So look at number 2, the domain of the graph. So remember, domain goes with the x. Domain goes from left to right. So obviously this is a very small graph, but numbers go out for eternity, correct? So if that line continued in both directions, the line would never stop going left to right. Even though it's going up, it's still going to be pointing to the right. So the domain is from negative infinity through positive infinity. Or in other words, we could say all real numbers. All real numbers. That's the domain. Now the range is not going down forever, because what's going to happen to this picture is that it's going to get, even though it looks like it's touching 0, it's getting closer and closer and closer and closer to 0. It's never going to actually be 0. It's going to be very close to 0. So the range doesn't go down for negative infinity. It doesn't keep going down. But if the way it goes up and off the page tells us that it's going to go up forever, right? So it approaches 0, and then it goes up for eternity. So the range of this graph is from 0 to infinity, positive infinity. And then number 3, what is the y-intercept? So there's 2 ways we can tell. One is we can see, oh, okay, well, this actually goes through the y-axis right here at 0, 3, right there. Or the other way, remember, is you look at what letter A is in the equation. So the y-intercept is 0, 3. We get that from both the function and the graph. All right, here's a good question. It says a wrestling match, it should say match, it says math. A wrestling match has eliminations each round. The table shows the number of wrestlers in each of the first 4 rounds of the tournament. Compute, oh my goodness, I am not doing well. It should say compute the average rate of change of f of x from x equals 1 to x equals 4 and identify the meaning of that rate. All right, so you guys remember to find the rate of change, or the slope, is y2 minus y1 over x2 minus x1. So we can use x1, x2, y1, y2, any of those, it doesn't matter. But actually, we're not going to do when x is 2 and x is 3. We're just going to skip all the way up here. So we're going to actually use, let me get rid of this stuff. I don't like my notations. Those look like exponents. All right, so let's use x1, x2, y1, y2. All right, so we're using y2. So y2 minus y1 over x2 minus x1. All right, so 9 minus 64 is negative 55 over 3. Negative 55 over 3. So it says, identify the meaning of that rate. So, oh, this is a multiple choice question. So it's asking, what is the average rate of change? Is it 55? Nope, we already figured that one out. It's not 55. Is it 3 over 55? Well, if we put our x's on top, it would have been, but that's not correct, is it? And then it says negative 55 over 3. Well, that's what we figured out it was. So on average, there were 55 fewer players for every round, every 3 rounds, which makes sense. So from round 1 to round 4, round 1 to round 4, we decrease the number of wrestlers by 55, right? So that does make sense. And then the last choice, of course, is 3. So we know that that cannot be the right answer. The rate of change is not 3. All right. All right, so now we're given a function. The function of x is equal to 5 raised to the power of x. It says section A is from 0, x equals 0 to x equals 1, and section B is from x equals 2 to x equals 3. Find the average rate of change of each section. All right, so let's do section A first, okay? So if we have a little t-chart, really I would put x and the function of x, but y can be substituted for the function of x, the output. So if x is 0 and then I want x to be 1, let's plug in our exponent. So if x is 0, what's anything raised to the 0 power? 1. And then what if x is 1? What is 5 raised to the 1 or the first power? The answer is 5. So if we do the change in y over the change in x, in other words, 5 minus 1 over 1 minus 0, well, 5 minus 1 is 4, 1 minus 0 is 1, so the rate of change is 4 for section A. That's our rate of change. Now let's do section B. So section B, we're going to do our input and our output. This time we're using 2 to 3. 2 and 3. So we want to know what is 5 squared. So 5 squared is 25. And 5 to the 3rd power, because remember what we're doing? We're plugging in for x. So if x is 3, 5 times 5 times 5 is 125. So now what is our change in y over our change in x? 125 minus 25 is 100. 3 minus 2 is 1. So our rate of change is 100. So that's different than this one, right? It's quite a bit different. And remember, it's because they're linear. This is not, it's not linear. It's non-linear, I should have said. So the constant rate of change is not going to be consistent. So just remember that. So now the next question is, how many times greater is the average rate of change of section B than section A? Well, how many times greater? That means we would divide. So the rate of change for letter B is 100. The rate of change for A is 4. So what is 100 divided by 4? So that would be 25. So it's 25 times greater in section B. Oh my goodness, I can't write. In section B. All right, and the question is, why is one rate of change greater than the other? And the answer is because it's exponential. The rate of change is exponential. It is not linear. Okay, if it was linear, it would be the same, but it's not linear, it's exponential. All right, I think that's all I have right now. All right, so I hope that helps you guys as you get started for this week, and then looking ahead. The lessons are tough and you guys have a lot to do. So hopefully I will get another video made for you by Wednesday, and I will post that if not earlier. But if you guys need me, reach out to me and I will help you out. All right, you guys, see you later.